So for today, I will give you a few differential equations for you to try to run and plot the phase space and try with different initial conditions, different sets of parameters, and so on for yourselves. Okay. So So what I'll take as an example are ones that I hope it will be easier because you're already studying that with Roberto, right? So so you more or less know where to look for stuff, okay? Yeah. So this will be how do I? Yeah. Okay. This will be one single equation, right? So single ODE is the one for a Lie effect, right? So a Lie effect. That is like this, right? So sure. I think there are several different ways to write. I like this one actually. N over A minus 1, right? So like this, right? I think Roberto prefers N minus A, I think, or something like that, right? So it doesn't matter, okay? So it's similar, yeah. But I think I prefer this version, yeah. With the provision that all three parameters are positive, and I think you have to set that A is smaller than K, right? Otherwise, it doesn't make a lot of sense, right? Yeah. Okay, and what I want you to do with this, I want you to look at this, plot solutions over time for different initial conditions, different sets of parameters. I want you to be able to check that it really goes to different final solutions over long times, depending on the initial condition and so on, right? I think you more or less know already how to look for that, right? Yeah? Or no? Yes? From the classes, Roberto's classes? Yeah? So since you already know that, it's more or less easy to know what you're looking for, right? Yeah? Okay, so this is, yeah? And the second one is the competitive loss of Volterra model, yeah? Or, yeah, competition loss of Volterra model, right? That is, I think Roberto uses this form here, right? The gn1 dt equals r1 n1 k minus n1 minus alpha n2 over k, k1, right? K1 and gn dt2 dt equals R2 N2 K2 minus N2 minus beta N1 over K2. Right? So this set of two differential equations, but now you see we have 1, 2, 3, 4, 5, 6 parameters, okay? 6 parameters. So what you see for exploring 6 different parameters, it's already quite uncomfortable, okay? Quite uncomfortable. So one thing that you can do is, that I suggest you try to do is to set R1 and K1 and K2, all of them equals to 1, okay? This is a suggestion, right? So you can also try without that, okay? And only change the other 3, okay? So alpha and beta are essential to change. R2, sometimes it's kind of interesting to see what happens if you also change R2, okay? Yeah? And then, again, what I want you to try to do, implement these equations numerically and look for different patterns. And again, this should be easy because you already know from Roberto's classes what are these patterns, okay? In which situation you should expect what kind of solution, okay? So in some situations, the initial conditions matter. In other situations, the initial conditions don't matter, provided they are positive, of course, right? Yeah. Of course, if you begin with one of them 0, of course, it's not a really good idea, right? So it just becomes a logistic equation. Yeah. Yeah. Is it clear what I want you to do? Yeah. No. So what I want you to do is take these equations, implement them numerically. So take yesterday's tutorial, implement them numerically, and then I want you to do is essentially is a series of solutions with plots. Okay, you go, you choose an initial condition, a set of parameters, plot it, and then try a different initial condition that will give you a different solution. Plot it again, or maybe plot it together with the other one if you want to compare them somehow. And for this one, you also can plot besides the solution itself over time. You can also plot the phase space, okay, that we discussed at the end of yesterday's class. Okay, also plot the phase space. Okay, in the phase space plot, sometimes it's interesting to also plot some lines that are the isot lines, right? Have you seen the isot lines already? Yeah. So, and also try to plot the isot lines together with the solution to see how this stuff happens. Okay. Yeah. Yeah. Does that look good? Yeah. So, okay. So I think it's quite some work. If you finish it too fast, then I can propose more. Okay. So there are infinite examples, right? But then I think this is pretty good to start. Okay. Yeah. So let's work. Yeah. Oh. Okay. Good. So work. Okay. Hi everyone. So our time is up for today. So just to finish the lecture. So a very quickly then message of hope that now you can look at your models and you can use these tools to see if your equations make sense and work the way you expect them to work. Okay, so this is the main idea, right? So I think you didn't have time to finish, but I think most of you could at least take few first solutions for the second one. Yeah? Yeah. Okay. Good. So yeah. Okay. So this is